Hi everyone, we're Team Minecraft Legends, analyzing commuter-trained ridership using machine learning. Here are our following team members: Amir Zafran, Kearney Leith, Lokman Haya, Nick Mohamachake, and Amri Amshah. The theme for today will become commuter. Now, as you can see, this is our non-pre-processed dataset that contains over 850,000 records of hourly passenger trips between stations from January until May 2025. So, what are the questions to help us to become rich? Here are the following 4 questions. The first question: classify high versus low ridership routes to prioritize resources. Secondly, to predict passenger counts to prevent overcrowding. Thirdly, to cluster stations by travel patterns for efficient scheduling. And fourthly, to forecast future demand for proactive planning. Now, before modeling, we pre-process data by encoding stations and days, handling missing values, and scaling ridership with robust scalar. Now, this pipeline will help us to optimize commuter services and maybe get rich along the way.
Hi, I am Amri. Today I'm presenting one part of our project where we use machine learning to classify whether a certain trip has high ridership based on where it starts and where it ends. Our goal was to train models that can predict if a route has high ridership, which we define as anything above the median value. The model that we use are Logistic, Regression, Random Forest, Regression, and XGBoost. To test the models, we split our data, 70% to train the model, 30% to test it. Then we measured how well each model performed using several metrics. The metrics that we use are accuracy, precision, recall, and F1 score. This is the data that we get after we train each model. You can see that Random Forest and XGBoost had similar strong results, while Logistic Regression struggled, especially in recall and F1 score. So conclusion for question 1 is Random Forest and XGBoost are strong models, while Logistic Regression is simple but limited.
So on to question 2, can we predict the number of passengers between station pairs based on time, day, origin and destination? This would be a regression problem. So for the goal of this question is to build machine learning models to compare the performance of each and every single model and to identify which features influence the ridership the most. The model that we use are Histogram gradient boosting, LightGBM and also XGBoost. As for the data preparation, we did feature engineering where we added a couple of columns in order to improve the accuracy model. We defined the features and the target and we split the data into 80% training and 20% testing set. For the performance evaluation, as you can see, for both MAE and RMSE, XGBoost scored the lowest score with a score of 2.2 and 6.87 respectively, and an R2 score of 0.59. Because of this, XGBoost is the best model. As for the feature importance, we picked based on the best model, which is XGBoost, and it seems that its peak hour and station pairs encoded are the features that influence ridership the most.
Good morning, I'm currently doing question 3. Can we cluster station pairs by similar travel patterns? First, we have to choose our models. I chose K-means because it's the simplest one. So step 1, I have to make this table, OD, timestamp and ridership using these codes. And step 2, I have to add the hour of the week, and then I have to min-max scalar and fit transform. And step 3, I'll use the elbow method to determine the K-means, which is K5 because it's large enough. So this is the graph of clusters, and cluster 0 is the one that picks in one direction only. Clusters 1 is the high pressure audit pairs where a lot of people go. Cluster 2 has a strong peak from Monday to Friday but no low weekend usage. Cluster 3 is the standard work school schedule, and cluster 4 is consistently busy from Monday to Sunday, indicating it's a shopping, vacation or travel station.
Okay, now moving on to question 4, which is to forecast future ridership for key station pairs based on past or relay patterns, which is a time series forecasting problem. So for this problem, there are 3 main key steps: data preparation, model training and evaluation. Just like any machine learning problem, we prepare the data first by creating the time and light features, defining the features and target, which is the ridership, and split the data into 2 sets, 80% for training and 20% for testing. So for this problem, we chose 3 models that are quite common for regression, which is LightGBM, Random Forest and decision tree. And for the evaluation, we chose 3 metric, which is RMSE, MAE and R square. And based on this table, we can see that LightGBM performed the best due to its lowest RMSE score and the highest R square score. And here are some visualization showing that LightGBM performed the best compared to Random Forest and decision tree.
In conclusion, our team explored a diverse set of problems: classification, regression, clustering, and time capabilities of machine learning. This approach shows how machine learning can solve real-world challenges across different domains, from predictions to pattern discovery and beyond. That's all for today. Thank you.